Hello friends, very good evening. In this video I'm going to discuss about the frustum. Frustum, you all know that when a cone is cut by a plane parallel to the base of the cone, then a smaller cone is removed and whatever is left, the remainder part of that cone is called as frustum. So this is a very popular and a little confusing mathematical idea. I'm just trying to explain you everything possible. So I have a cone which has got the height capital H and the capital R, and from which a small cone is removed from the top, and this cone have the vertical height H and R. Now let's establish the similarity between these two. Since you know that the cone can be obtained by rotating a right angle triangle along its perpendicular sides, so the vertex angle, this is the one angle, is at 90 degree, and these two angles are the common angle of the cone. So by angle symmetry, these two cones or these two triangles are similar. And when we know that if these two triangles are similar, then their corresponding sides are proportional, means they have certain proportionality between them. So I write capital H upon small h, capital R upon small r, and the constant of proportionality is K. So if you know the volume of the cone is 1/3 pi capital R square, this is the volume of the bigger cone. So pi R square capital H upon smaller v is volume for a smaller cone, which is 1/3 pi small r square small h. So 1/3 pi cancel, and then you find that it is r square h upon r square h. So just try to keep r upon r whole square together. So this gives you a scale factor of k cube, where k is the proportionality constant, which is h upon r. So for r square upon r square, you can write k square, and here I just write r upon r whole square. Okay, it's not working, space is not here, so I write somewhere else. So I will write v, capital V upon small v equal to capital R upon small r whole square, and this ratio is called the proportionality constant, or constant of proportionality, or the proportionality constant, and this is h by h. So both are r by r and h by h are just represented as k, so it is k square dot k. So this will become k, and for those who have studied the idea of the similarity and the mathematical model, they understand that the ratio of the volumes are the 3 times the scale factor, and the ratio of the surface areas are the 3 times of the scale factor, and the ratio of the dimensions are the 1 time of the scale factor. So using this idea, I'm just trying to find out the volume and other important features like the remaining surface area, all of the cone. So slowly I back into the code, and then I create a class called class cone. And then the main important features, what I think is that frustum is made just by truncating the cone by a plane parallel to the base of the cone. So from which height it is cut, that plays a great role, and then the original dimensions of the cone also plays the great role. So means we have 3 important variables, that is the capital R, which is the original radius of the given cone, then capital H, which is the original vertical height of the cone, and then small h, which is the vertical height from the top, is the height from the top where the cone has been truncated. This is the main 3 parameters, and the user will be inputting these 3 things: capital R, capital H, and small r. and we know that the slant height of the cone is square root of r square plus h square. So using the same formula, I'm initializing one more variable called self dot L. So I have got the self dot capital H, self dot capital R, and self dot capital L. If required, we can add the more variable to it. For that, I import, since I'm using sqrt, so I have imported this import math. Now I design one more function, and the job of this function is to calculate the scale factor, because uh, by what I'm using the idea of self dot h upon small h, means the original height of the cone divided by the height from the top of the tip of the cone from where it has been cut. So that will give you my k, that is called the constant of proportionality, which I discussed in the mathematical part of this one. Now this is a function, I call it the def recovered cone, means suppose if you want to find out the volume, because this cone, smaller cone, is removed from a bigger cone from the top, so both the cones are similar, and the volume of the cone, you all know, is 1/3 pi r square h. So I declare one more variable which I think is important, because I felt like the height, the from the tip where the cone is cut, should also be passed by the user. So I made just one little change. So means the user is passing the all these three important variables, and now it is fine. So I define the volume of the recovered removed cone, like that is 1/3 pi r square h, and I just call it the volume of the cone. Forget it. Sorry, I'm just sorry. Now I create one function called volume, and that is return math dot self dot capital R into self dot capital R into self dot capital H. So this gives you R square H divided by 3. So now I want this function remove cone. This, since you know that the ratio between these two volumes, the original volume and this volume, is the v upon the 3 times the scale factor, means k cube. So I write the self dot volume into, I'll call this function, and its value will be multiplied 3 times. So self dot r factor, and this r factor is actually your k, so this will be multiplied 3 times. So this into r factor, self dot r factor into, so this one gives you the idea of v, capital V volume upon the 3 times the scale factor, means k cube. V upon k cube is the small v, means the volume of the removed cone. We are using pure mathematics. I will explain you again at the end, but the volume of the bigger cone and the smaller cone are having a proportionality relation, and that is k cube. So v upon v equal to k cube, so v upon k cube equal to small v. So that's why I use this function mathematical idea, because we need to just input the value and get the result. How we are getting the result, this is our mathematical, and this is our you can say the programming acumen on which the things are dependent. Now I remove the surface area. So now you know that surface area is like, suppose you have a cone, so it has a lateral surface area and the base, if it is a solid cone. Then when you remove that part, so the lateral surface area of the smaller part is removed, and one more surface, the top surface which comes up after truncating, should be added, means pi r square will be added. So the total surface area minus the surface area, yes, the lateral surface area of the removed cone, plus pi r square, where the r is the radius of the top of the truncated cone, which we have found just after removing that smaller cone from the bigger cone. So this I am just trying to achieve. with this help of this function. So the idea is of total surface area. Total surface area of this bigger cone is what? Pi RL plus pi r square. Pi RL is the lateral surface area and the pi r square. So we can also write the pi r common, pi r plus L. So self dot like the mat dot pi into self dot r bracket into self dot r plus self dot L. So now I remove the L surface area, means the surface area of the frustum. So surface area of the frustum, what I was just telling you just a little before, that the surface area of the frustum is the total surface area of the bigger cone minus curved surface area or the lateral surface area of the smaller cone plus area of the top of the small circular section which we have got after truncating the cone from that position. So that is pi r square. So pi, that radius you can call it as small r, because after the truncation the frustum will have the two circular end. So the base remains same and the new circular end which have come from the top is also circular in nature, and that radius is the radius of the smaller cone which has been removed from the bigger cone. And I hope that you understand. So just go to the programming, but those who are good in mathematics, they can understand, it's not a very big deal. But those who are new and they want to understand, because I have seen the programmers struggling to cope with the difficulties coming from the mathematics. So just you write the thing, and I'll explain you at the end. Just write the follow the statement, which is self dot TSA, means the total surface area of the bigger cone minus this statement. Just you write the code and then you can find that it's working. And at the end again I have explained that what I'm trying to do or what I'm trying to say. But just now theoretically you can say that total surface area of the frustum, because it has two ends, both are circular, so it's pi r square and other is also pi r square, and the lateral surface area which also somewhere is called as curved surface area, from that the curved a little area of the smaller cone has been removed. So the total surface area of the bigger cone minus curved surface area of the smaller cone, plus you have to add, because when you remove that cone another circular area comes up at the top of the frustum. This is what I'm trying to do. I think I made myself a bit clear. Just look at the code, and if you are still getting confused, then I'll suggest that write the code and remove everywhere like the self part. So just become like the TSA minus pi r square, something like that, and then you'll understand by my further explanation which will come from the bottom. So now this is the volume of the small volume, this is the volume of the removed cone, this you can say, or the volume of the frustum. So this is the volume, because volume means from a big volume a small volume is lost. So self dot big volume minus smaller volume, means the volume of the bigger cone minus volume of the removed cone is the volume of the frustum. Okay, now the main part, let me receive some information from the user. One by one I will receive the capital R, that is the radius of the given cone, and then the capital H, which is the height of the given cone, and then the small h means the height from the top, from where the smaller cone is removed to make it a frustum. So capital R, capital H and small h. I think I have made myself abundantly clear. If still you find any problem, then better you write in the code. I will explain you, don't worry. So copy paste, and then I change something like the radius, height, and this is small h, r h, I just try to make it same so that you can understand what actually they are. So I create one object of the cone class and pass these three values. So the volume of frustum equals plus I have yet to complete the create the object. So okay, let me create the object here. So I call con equals cone and pass these three value, capital R, capital H and small h. Okay, so this str, then I'll call the function which is required most right now in your code. If you want to write the more, you can call other function, then also you can keep on calling them and checking what the value they are returning. So one more function call, this is the for the surface area of the frustum, because that is our target, to find the volume of the frustum and surface area of frustum. Okay, so in this program I just try to complete. Okay, here I think I need to make some changes, so let me adjust the factor here. Okay, now hopefully everything is okay. Let's see. Result only says now here. Oh, here I need to make these changes because that was not correct. Now let me run this code. So let me enter. I have got one example, and that data I'm using. If it matches, you can use your data also. Now yes, it's working nicely, thank you very much. Now listen to the mathematical part again. So these three cones you see, now you see the ratio, capital H upon small h, capital R upon small r, and capital L upon small l equal to k, and that is called as ratio constant, because when two triangles are similar, their corresponding sides are proportional, and these two triangles are similar because their angle, vertex angle, both are 90 degrees, and one angle from the top that is also common. So by angle test, these two triangles are similar, and so this is the height by height, like the height of the original cone upon height of the removed cone, radius of the original cone upon radius of the removed cone, and slant height of the original cone upon slant height of the removed cone, all have the ratio factor, that is k. And surface area factor, surface small s upon capital S, means the removed cone represents small things and the big is capital S. So S upon S is 1 upon k square, this is scale factor, and for the volume it is k cube. So that's why to find out the volume of the removed cone, I simply use the relation capital V upon k cube. Now I think it's clear. Practice more and just try to understand, because it is more mathematical in nature rather than you can say the programming. Because if many times in our life I have seen that, like if you're not good in mathematics, if you're not good in logic, then the programming will become boring and it will become headache. But if you are good in mathematics, if you are good in logic and reasoning and pattern, because mathematics is also pattern recognition, and the computing is also understanding the pattern and manipulating them. So this is the height equal to hk, because capital H equal to small h into k, capital R equal to small r into k, and capital, yeah, see the relation. I just try to find out the relation, same thing with height, and this is the